Welcome to this explainer on the biological treatment for depression. If you're deep into your GCSE revision and looking to completely master how the brain's chemistry affects our mood, you are in exactly the right place. Today, we're going to break down the science of synapses, neurotransmitters, and how medical treatments actually intervene to help those suffering from depression. Let's get into it. Here is our roadmap for today. We'll be covering 1. The synapse, 2. Synaptic transmission, 3. Neurotransmitters and depression, 4. Antidepressant drug mechanisms, 5. Treatment evaluation, and finally, 6. Exam recall. All right, Section 1, the synapse, the basic building block. So you probably know the structure of a standard neuron, right? It's the nerve cell that helps the brain send signals around the body, and it's got a main cell body, a long axon, and terminals at the end. But the absolutely essential thing you need to know for your exam is this. These individual nerve cells do not actually touch each other. Because they don't touch, we've got to talk about the space between them. Now, it is super important to remember that the synapse is way more than just an empty gap. The synapse is the entire connection zone. It explicitly includes the end of the first neuron, which we call the presynaptic neuron, the actual physical gap between them, and the start of the next receiving neuron, known as the postsynaptic neuron. It's the whole shebang. Moving right along to Section 2, synaptic transmission, sending the signal. This communication happens in a beautifully sequential process. First up, an electrical message reaches the very end of the presynaptic neuron. This triggers the release of chemical messengers, our neurotransmitters, straight into the synaptic gap. These chemicals float across that tiny gap and bind to specific receptors on the next neuron. Once they attach, boom, it triggers a brand new electrical signal in the postsynaptic neuron, allowing the message to continue on its journey. It's basically an amazing relay race, going from electrical to chemical and right back to electrical. You can picture it like this. Those little chemical messengers drop out of the sending neuron, float into the gap, and securely lock into the receptors on the receiving side. It's literally like a key fitting perfectly into a lock. That is exactly how nerve cells communicate. Okay, learning is all about active recall, so grab a whiteboard or piece of paper, pause this explainer right now, and draw and label the synaptic transmission process yourself. Draw the presynaptic neuron, the gap, the neurotransmitters, and the receptors on the postsynaptic neuron. Seriously, give it a go. I'll be right here when you're ready. Awesome. Let's jump into Section 3, neurotransmitters and depression, the chemical messengers. So, different neurotransmitters have very different jobs in the brain. For your GCSEs, you need to be really familiar with two main ones, serotonin and noradrenaline. Serotonin is heavily involved in regulating our mood, our sleep patterns, and our appetite. Noradrenaline, on the flip side, is primarily involved in our levels of alertness and our physical responses to stress. Both are absolutely key, but they have totally different primary jobs in how they affect what we think, feel, and behave. Naturally, if neurotransmitter levels are too high or too low, it dramatically affects us. For instance, if a person has abnormally low levels of serotonin, they might feel incredibly low or clinically depressed. This shows us exactly how a simple chemical imbalance at the synaptic level can literally drive these severe biological symptoms of depression. Which brings us nicely to Section 4, antidepressant drug mechanisms, fixing the flow. There are 4 main types of antidepressants used today. We've got SSRIs, which target serotonin, SNRIs and TCAs, which target both serotonin and noradrenaline, and MAOIs, which target serotonin, noradrenaline, and dopamine. That's a lot of acronyms, right? But despite these different names, they generally operate using one of just 2 primary mechanisms. They either block reuptake or they stop the breakdown of the chemicals. Let's look at that first mechanism, used by SSRIs, SNRIs, and TCAs. Normally, there is a reuptake transporter on the presynaptic neuron that acts like a little recycling pump, pulling neurotransmitters back inside to be reused later. Well, these antidepressant drugs physically block those transporters. By stopping serotonin or noradrenaline from being sucked back in too soon, the drug forces those feel-good chemicals to stay in the synaptic gap much longer, and that is what ultimately boosts the patient's mood. Alternatively, we have the MAOIs. These work a bit differently. Instead of working in the gap, they actually work inside the presynaptic neuron itself. They stop the breakdown of neurotransmitters by blocking the specific enzyme that normally destroys them. Because that enzyme is blocked, way more serotonin, noradrenaline, and dopamine are preserved inside the cell, meaning a much larger amount can be released into the synapse to improve mood and reduce depression.
Section 5 now, treatment evaluation, strengths and weaknesses.
Let's kick off with a major strength. The data shows that 50 to 60% of patients with moderate to severe depression show significant improvements after being given antidepressants. To put that into perspective, only 20 to 30% show improvement when treated with a placebo pill, so it definitely works for a lot of people. This is a huge benefit because improving a patient's mood with drugs can give them the exact motivation they need to commit to other long-term therapies, like cognitive behavioral therapy.
However, we have to impartially look at the weaknesses to have a balanced evaluation. First off, these drugs treat the symptoms, the low mood, but they don't tackle the root maintenance of depression, like genetics or negative thought triads. Because of this, there are pretty high relapse rates once a person stops taking the medication. Secondly, they can cause highly unpleasant side effects, nausea, dizziness, poor sleep, and even suicidal thoughts, which can definitely cause patients to quit the therapy entirely. Finally, look at the numbers. 40 to 50% of patients do not show improvements. Individual differences are huge, and these drugs simply do not work for every single patient.
Let's wrap things up with Section 6, Exam Recall, putting it together. Grab your whiteboard or pen one last time. I want you to pause this explainer and try to write out a 2-sentence answer explaining how antidepressant drugs work. This is a standard 2-mark exam question. Try to use sentence starters like, antidepressant drugs work by, and the drugs increase the amount of. Give it your best shot. Welcome back. So here is your model answer. For your first mark, antidepressant drugs work by raising the levels of neurotransmitters such as serotonin and noradrenaline, which are thought to play a role in controlling mood. And for your second mark, the drugs increase the amount of these neurotransmitters or prolong their effects at the synapse. This helps to control our mood and reduce the symptoms of depression. If you wrote something close to this, you totally hit the nail on the head. You are proving you know exactly how increasing neurotransmitter levels at the synapse works. You've done a fantastic job covering a ton of complex biological science today. As you continue your revision and think about the strengths and weaknesses of drug therapy, I'll leave you with this provocative thought to consider. If biological treatments only manage the symptoms without tackling the underlying maintenance of depression, can we ever truly cure it with a pill alone? Something to chew on. Keep up the great work with your studying, and I'll catch you in the next explainer.